Hi, in this video I will discuss how to solve speed time graphs in kinematics. And the question is, the figure 2 shows speed time graph for the model of motion of an athlete running a 200-meter race in 24 seconds. So the athlete starts from rest at time t equals to 0 and accelerates at the constant rate, reaching a speed of 10 meters per second in t equals to 4, like in first 4 seconds. So in first 4 seconds, so the athlete starts from 0 and accelerate and reach to the speed of 10 meters per second in first 4 seconds. So then moves a constant speed of 10 meters per second at from t equals to 4 to t equals to 18. So from t equals to 4 seconds to t equals to 18 seconds, then it actually moves with a constant speed of 10 meters per second, and then decelerates a constant rate from t equals to 18 seconds to t equals to 24 seconds from the finishing line with a speed of u meter per second. So then athlete start decelerating from t equals to 18 seconds to 24 seconds and reach to the finish line with a speed of u meter per second. All right, so the question is, use the model, find the acceleration of the athlete during the first 4 seconds of the race and state the units of your answer. So we need to find the acceleration of the athlete in first 4 seconds. So since it is a speed time graph, right, if you have the velocity time graph or the speed time graph and they ask you to find the acceleration, you need to find the gradient of that line. So we need the gradient of this line, right? So for the gradient of this line, you can see you need change in y, which is 10. Change in y is 10 and the change in x is 4. So then acceleration for the part A would be 10 over 4, change in y over change in x. So 10 over 4 is same as 5 over 2, so it's 5 over 2 meter per second square is the acceleration of the particle, is the acceleration of the athlete in the first 4 seconds. All right, so the part B is find the distance covered by the athlete during the first 18 seconds of the race. Now we need to find the distance. So in a speed time graph or in a velocity time graph, if you're supposed to find the distance, we need to find the area under the curve. So we need to find the distance covered by the athlete in the first 18 seconds. So that means we need the area of this part of the shape. So you can see this is the trapezium, right? And in this trapezium we need this parallel side length, which is 18 take away 4, and this length is 18, right? And we need the distance between them, which is 10. So now if we work out the area of this shape, it is the trapezium, so the area of the trapezium would be half times by the sum of the parallel sides, which is 18, plus 18 take away 4 is 14, times by the distance between them, which is 10. So if you do this on the calculator, it would be half, which is 0.5, times 18 plus 14 times 10. So it is 160 meters is the distance. So the distance covered in first 18 seconds up to here is 160 meters. All right, now in the part C, they ask you to find the u, like the velocity with which athlete reach to the finish line. So we need to find this u, like the speed with which athlete reach to the finish line. Okay, right, so now we already know that the total distance covered by the athlete is 200. So that means the total area under the complete curve shape, or you can say the total area of the figure should be equals to 200 meters, because the total distance covered by that athlete is 200 meters. Since the total area is 200 and this area we already worked out in the part B, which is 160. So since this is 100, this area is 160 and the total area is 200, so this area would be 40. So we know that this area of this part is 40 meters. Now let's figure out the area of this part. Okay, now This is again a trapezium with these two parallel sides, and this one is the distance between the parallel sides. All right, so this side has the length of 10, this side has the length of u, and 24 take away 18 is 6. So these are the lengths we need to find the area of this part, and this area is 40. Now that means area would be half times by the sum of the parallel sides again, so 10 plus u, times by the distance between them, which is 6, and this area is 40. So 40 equals to this expression, so which is 6 divided by 2 is 3 times 10 plus u, and if you take 3 inside, so it's 40 equals to 3 times 10 is 30 plus 3u. If you take away 30 from both sides, so it's 10 equals to 3u, and divide by 3 on both sides, so 10 over 3u is the answer. So u is 10 over 3 meter per second. So athlete reach to the finish line with this speed. So this was the question. Thank you so much.